Okay. Name two right angles in this figure. And when you say it, I want you to say it with the part of it like angle and then the letters. Okay, Bella.
Angle BEC.
Angle BEC. Give me a yes or no if you agree if that's the right angle. Okay. Okay. Oops. Angle BEC. All right, and another one, Sophia. Angle AEB. Give me a yes or no. Okay. Angle AE. Would you say B? Angle AEB. So this angle and this angle were the two angles that we got. All right? And this is good review for you too, Akaya. All right, name two line segments. Brian.
D and B.
Oh, you have to give me the whole thing.
Oh. Line segment DB.
Line segment DB. Line segment is just straight line. I'm sorry. You said D.
Arrows at the end.
Excuse me. Should it have arrows? Okay. Why, Haley? Why doesn't it have arrows?
Because line segments just they don't go on forever. They stop at a certain place.
Remember, the arrows mean they go on forever. Okay. So another line segment. Ronnie.
Line segment AC.
Line segment AC. Did anybody do line segment D, the shorter version, with an E in it? Like an EA or an EB. Okay, so you could do those too. We could have had line segment EB, line segment EC, or CE. Remember, it doesn't matter on the segment what order the letters go in. Does it matter on the angles what order it goes in? Yes?
Yes.
And what is the rule with the angles? Jalen.
The middle one.
Which is called the
Vertex.
vertex. Very good. The middle letter has to be the vertex. In this case, it's the E. Okay? And the other two letters, it doesn't matter. I could have done C, E, B, and it would be the same thing. All right, name two rays. Ethan.
Ray ED.
Ray, E, D. Ethan, tell me what I'm going to put on the top to show that it's a ray.
But, you have to put on top.
I'll start with that. Now what do I do?
At the far right, you have to put an arrow.
On the right side, we put an arrow. Does it matter, Ethan, what order the letters go on this one? Look at Sophia's
Yes,
head.
because the one in the middle that doesn't have a line has to be at the front.
Okay, so it does matter because it shows us it's starting at the dot E and then continuing through D and then continuing on forever. So this one does matter, the order. All right, Preston, can you give me another ray?
ABC.
Can we just do two letters?
Yeah.
Can we do ray AC?
Yeah.
Does AC work as a ray?
Yeah.
Yes, it does. It tells us it starts at A because there's a dot there. So it can start at A and then go forever through C. So A, C. All right? And then two lines. Who would like to give me an example of a line? Jaden.
You put a line.
Okay.
Arrows at each end.
Okay.
Line DB.
DB. How many of you agree with that? DB. Does it matter what order, class?
No.
No, it doesn't matter what order. All right, Lydia.
Line. Arrows at the end.
Like this?
Yeah. And then CA.
CA. How many of you agree with that? Okay. Does it matter what order?
No.
It does not matter what order the letters go. Okay.
California.
California, like California Gold Rush. All right, we're in 10-3 today. Go ahead and turn to. You can find models of lines in the world around you. For example, two streets that cross each other. Model intersecting lines. Metal rails on a track that never cross model parallel lines. Now let's talk about intersecting lines that are a road. raise a quiet hand if you can think of one place where two streets come together and they cross. If you can think of some place where there's a stoplight, two streets come together and they cross each other. You guys drive them all the time. Well, you don't drive, but your parents do. When those two streets come together, like this, right? What is that part in the middle called? Does anybody know? Tony? They're in intersection. Okay? So if you have two roads that come together like this, where they meet in the middle is called the intersection. How many of you have heard your parents say that? The intersection. It's because that's where they intersect. That's where they cross each other. Okay? So, intersecting lines are lines in a plane that cross at one point, and that's it. They form four angles. They could be, have you ever seen roads that come to each other this way? Kind of sideways? They don't have to be perpendicular like this one. They can be any two streets, not just streets, but any two lines that come together and cross at exactly one place, forming how many angles? Four different angles. You can see an angle here. You can see an angle here. You can see one here, and you can see one here. Four angles. Okay? So, line HI, and we just talked about naming lines, line HI intersects line JK at point X. Okay? On our drawing that we started with, those lines intersected at what point?
E.
Point E. At an intersection. Very good. At an intersection, and it was called point E. This is how we would draw it. Line HI and JK intersect at point X. Okay? That's how we would write it. This is how we say it. This is how we'd write it. Then it talks about train tracks. You can have train tracks that are near each other. What happens if the train tracks cross each other? What's going to happen, Ethan? Yeah, they don't have stop signs like we do most of the time. There are some places where trains actually do cross each other. But overall, trains run parallel to each other. That means right next to each other, never, ever, ever crossing because we don't want them to crash. Okay? Parallel lines are lines in a plane that are always the same distance apart, and they never cross. So, however far they are here is the same distance here. I want you guys to think for a second. Why is it important to know that they're the same distance apart all the way through? What would happen if they weren't the same distance apart all the way through? Who would like to explain to me why it's important that the parallel lines stay the same distance apart all the way through? Okay, so if we're talking about trains and the E and D are closer, they might have a more chance of crashing. What if this was 1 mile and this was just 3/4 of a mile apart? So they're still pretty far apart. They're not going to crash into each other at 3/4 of a mile, right? 3/4 of a mile is pretty far. It's further than it is from here to your houses, most of you. So thinking about it that way, they're not going to crash into each other because they're running next to each other at 3/4 of a mile. What other problem might they have? I know that Harish knows. Harish, why don't you explain what you were saying? Okay, and so he was showing us with his hands, basically like this. They're coming at it, if they're closer here and they're further at my palms, eventually those trains are going to cross. So it doesn't matter that it's 3/4 of a mile apart. If it continues, if we continue this line, and this is if this is our line, here they're a mile apart and here they're 3/4. So they're a little closer, but they're not crossing, right? So if I draw this line, and I draw this line, eventually they cross. Okay? That was not a very good drawing. So they have to remain the same distance apart to never cross. Because remember, they're a line they go on forever. So remember, they have to stay the same distance apart. That's important. Which means that they don't ever cross. Okay? Line DE is parallel to line FG, is how we would say it. And this is how we would show it. DE, line DE is parallel to FG. Let me show you what that looks like in bigger form. Line DE is parallel to FG. They're parallel lines, so it makes sense. Do they have to be perfectly parallel? No. Don't spend too much time trying to make perfectly parallel lines. It's not going to happen. But the point is, I can read this and say line DE is parallel to line FG, and I know exactly what that means. It means that. Two lines that are never ever going to cross each other. Okay, now let's look at the perpendicular. This is just like the example I drew on the board. Perpendicular lines are lines in a plane that intersect to form 4 right angles. Now when I had you name the right angles, I only did one of those, didn't I? But we know that all 4 have to be right angles. If one of them is a right angle, all 4 are right angles. So again, if one of the angles is right at the intersecting lines, then they're all right. How many right angles do I have here, class?
4.
Okay. Could I have just one right angle at that intersection?
Yes.
They're intersecting lines. If it has one right angle, it has 4. You cannot have just one or just 2 if the lines are truly intersecting lines. So if they're intersecting lines and one angle is right, how many angles are actually right?
4.
All 4. I want to make sure you guys understand that. So line LM is perpendicular to line NO. Okay? The way we would draw that is this way. And again, I'll write it big for you. Line LM is perpendicular, little upside down T, to line NO. Okay? The little upside down T shows perpendicular. You kind of make it look like it has a right angle, but you don't have to draw the little right angle in. You just draw the little upside down T to show perpendicular. You could have 3 lines that are parallel, and you would write them just like this, and then which is parallel to HI. Maybe all 3 of those lines are parallel. So yes, you can have more than one parallel line. There can be 3. The other thing is, when I told you that if you have 2 lines that intersect like this, you have 4 right angles. However, this can also be, you can have a ray that is perpendicular to a line. This is also called perpendicular. And that forms how many right angles? 2. This one and the one on the opposite. Tell how the streets appear to be related. So if we have a map over here, right? Here's a map. West 36th Street. Find that in your book. West 36th Street. How do they relate to each other? Are they perpendicular, parallel, or intersecting? Raise your hand when you know. Intersecting. You can go ahead and write it. Now let's look at West 35th. Here's West 35th and 7th. How do those appear to relate to each other? What did you guys decide? They are perpendicular. They're perpendicular because if you look at it, they do form a angle even though they look sideways, and that's something important to see. That even though on the paper they look kind of just regular old intersecting, if you look at it, if you turned your paper, now all of a sudden they do look perpendicular, don't they? Right? And you can see with the little arrows here even that it looks perpendicular. Okay? So the last one is the West 37th, which is this one, and West 36th, which is this one. What do you guys think? Parallel. Okay? Go ahead and write. Draw and label ray YX and YT. So I'm first going to draw my ray Y, Z. Go ahead and draw your straight up. Because they have to be perpendicular, and meet at a right angle, I have to draw it straight up, or straight down would have worked. And I'm going to label it. Now remember, they connected at what point?
Y.
Okay, so it tells you right here, they intersect at point Y. So look, they intersected at point Y. What is the figure we drew? What is it? A line? Is it a segment? Is it a, what is it?
Right angle.
But plainly, it's just an angle. Now, if we classify it, then we throw the next word in, which is right angle. Go ahead and explain in words why you know that this angle forms a right angle. What about this problem? Ensures that it's going to be a right angle that you make? Why does perpendicular, how does that explain why I know that it's a right angle? Perpendicular means all right angles. Right? Perpendicular means all right angles. If two rays connect, they connect at one right angle. That's part of the definition. If we had, remember I said if we had a line and a ray, this would also be considered perpendicular. We could call that perpendicular, and then we have two. And if we have two full-on intersecting lines, then we have how many right angles?
4.
Part of the definition. They form a right angle. Draw and label segment QR is parallel to segment ST. How do I know that they're segments? The little line on the top tells me it's a segment. So I'm going to draw two lines that appear to not intersect. Am I going to be perfect? No, but my goal is to make them not intersect. Actually, it's a segment, so I'm going to do this. And then I'm going to make the next one appear to not. Do those look pretty parallel? Yeah, this one we're going to call QR. Oops, we're going to call that Q and this R. And I'm going to call this S and this T. Why would they not be arrows? Nope. Not if I'm going to draw it. If I'm taking it like I took it off the board earlier and I made you pick segments, you can pick from dot to dot even though they have arrows. But if I'm just going to draw it, I'm just going to draw the segment. All right, look at the figure over here. Name two sides that appear to be parallel. We don't know for sure, but they look like they're parallel.
CB and DF.
Okay, CD and DF?
CB and DF.
Okay, so segment, because they're segments, they're not lines. Segment CB is parallel to segment DF. And it shows you right here, CB and DF. Okay? Are there any other lines that appear, or sides that appear to be parallel? What do you think, Akaya? Are there any other lines that look like they might be parallel to each other there? BF. Okay, so that would be this line. What line would be parallel, or what segment would be parallel to it? CD. So BF is parallel to CD. And we're calling those segments. Oops, that should be up here, sorry. BF is parallel to CD. So two sides that appear to be perpendicular. CB, segment CB is perpendicular to what? So CB is perpendicular to BF. Okay? Is there another one? Really, can you see another one where they're perpendicular? CD, so that's this one. CD is perpendicular to DF. Very good. DF. Are those the only two? This one we only had the two parallel lines. Are these the only two segment or sides that are perpendicular to each other? Give me a yes or no. I have the half. No, we don't think so. So raise your hand if you would like to give me another set of perpendicular sides. CB is perpendicular to CD. Okay? And there's one more. BF is perpendicular to DF. So basically all four corners.